While Hilary's dance appears effortless and graceful, it is an artistic expression of human movement that can be explained from a physics perspective. Stated simply, Newton's second law says that the sum of forces on a body is equal to the rate of change of its linear momentum. Because Hilary's mass does not change, you can think of the rate of change of her linear momentum as the acceleration of her mass. What is a force? A force is a push or pull and is represented by a vector. Force vectors are arrows that must have three things: a length to show the amount, a direction, and a point of application. To explain Hilary's acceleration, we need to account for all of the forces acting on her body. One of these forces is the force due to gravity, also known as body weight. As long as Hilary stays on Earth, her body weight stays the same and pulls her towards the center of the Earth. Where is the body weight force applied? Hilary's body can be represented as if her mass is concentrated at a single point. We call this the center of mass. You could think of this as the balance point. If we freeze Hilary and suspend her from one part of her body, we can see that her mass is equally distributed on both sides of the line. If we suspend her from another part of her body, the intersection of these lines is Hilary's center of mass. If Hilary changes her body shape, her center of mass also changes. What other forces act on Hilary? She doesn't fall to the center of the Earth because her contact with the ground creates a force. The force between her feet and the ground is called the reaction force. When Hilary pushes on the ground pushes back on her at the center of pressure. This is where Hilary feels the force when she is in contact with the ground. In this case, when Hilary is still, the reaction force is equal in length and opposite in direction to the body weight force. For Hilary to accelerate forward, she needs to generate a reaction force in that direction. She does so by leaning forward and then pushing on the ground. The horizontal part of this reaction force causes her horizontal acceleration. When Hilary jumps, she accelerates off the ground because the reaction force is larger than her body weight. Muscles can also create forces. See if you can accelerate the outer edges of your mouth to match Hilary's smile.